Check.
Check.
All right. Ladies and gentlemen, esteemed researchers and valued guests, a very good evening to you all. In the realm of academia, where curiosity knows no bounds and innovation thrives, we find ourselves gathered in the esteemed Moratuwa Engineering Research Conference 2023, MERCon 2023. This conference serves as a melting pot of ideas, a crucible where theoretical knowledge meets practical application, and where the future of engineering is envisioned and crafted.
MERCon 2023 is the 9th International Multidisciplinary Engineering Conference organized by Engineering Research Unit and IEEE student branch of University of Moratuwa. MERCon is technically co-sponsored by IEEE Sri Lanka section and IEEE Robotics and Automation Society Sri Lanka.
MERCon 2023 represents not just a moment in time, but a culmination of countless hours of dedication, passion, and scholarly endeavor. It embodies the essence of the academic pursuit, the relentless quest for understanding, the desire to solve complex problems, and the determination to make a meaningful impact to the world through engineering excellence. Before we embark on this enlightening journey, it is my great privilege to invite the distinguished individuals who have contributed significantly to the academic tapestry of our institution to join us at the head table. Dean, Faculty of Engineering, University of Moratuwa, who is also the professor in the Department of Electrical Engineering, Professor Udayanga Hemapala. Dean, Faculty of Graduate Studies, who is also a senior professor in the Department of Chemical and Process Engineering, Senior Professor Ajit D. Alvis. Director Research, University of Moratuwa, who is also the head of medical technology in the Faculty of Medicine, University of Moratuwa, Professor Ruwan Gopura, General Chair of MERCon 2023 and Chair of IEEE Sri Lanka section, and also a professor in the Department of Electrical Engineering, Professor Buddhika Jayasekara. And last but not the least, Director Engineering Research Unit and Program Chair of MERCon 2023, who is also the Senior Lecturer at the Department of Computer Science and Engineering, Dr. Sulochana Surya Arachi. Ladies and gentlemen, please join me in extending a warm welcome to our distinguished guests. Their presence here not only honors us, but also signifies the wealth of experience and knowledge that we are privileged to have within our midst.
With our esteemed dignitaries seated, I encourage each one of you to embrace the spirit of curiosity, engage in thought-provoking decisions, and make the most of this enriching experience. Thank you, and let the enlightening session of MERCon 2023 officially begin.
It is now my distinct pleasure to invite a visionary leader, the driving force behind MERCon 2023, to the podium. His unwavering dedication and commitment have transformed this conference into a beacon of knowledge and innovation. Please join me in welcoming the General Chair of MERCon 2023 and Chair of IEEE Sri Lanka section, Professor Buddhika Jayasekara, to deliver the welcome address.
Good evening to all. Our honorary chair may be available online. Keynote speaker, Professor Jason Maas from University of Michigan, USA. Professor Udayanga Hemapala, Dean, Faculty of Engineering. Professor Ajidya Alvis, Dean, Faculty of Graduate Studies. Professor Ruwan Gopura, Director Research, University of Moratuwa. Other heads of the departments. Representatives from IEEE Sri Lanka section. Mr. Dhammika Marasinghe, Vice Chair. Representatives from IEEE Robotics and Automation chapter. Other financial sponsors and their representatives. Faculty of Graduate Studies, Swisstech Aluminium, Octave, Metropolitan Apparel Technologies. Dear authors, colleagues, ladies and gentlemen, it's my great pleasure and privilege on behalf of the organizing committee of MERCon, which includes Engineering Research Unit, Faculty of Engineering, University of Moratuwa, IEEE Student Branch, University of Moratuwa, to welcome you here today for the 9th International Conference, MERCon, Moratuwa Engineering Research Conference, MERCon 2023. We are delighted to have you with us to participate in the 9th version of MERCon, making the journey of transforming ERU, Engineering Research Unit Symposium, into a Scopus Index international conference with an H5 index of 18. I hope you had a wonderful experience as authors, presenting papers, listening keynotes, interacting with researchers, and overall conference experience. Finally, I would like to extend warm wishes, welcome to all of you for this milestone award ceremony, MERCon 2023. Thank you.
Ladies and gentlemen, please join me expressing our heartfelt gratitude to Professor Buddhika Jayasekar for his inspiring welcome address and also his exceptional contributions to MERCon 2023. We are deeply honored to have your guidance, Professor Buddhika Jayasekar. With that, it's my privilege to invite the Dean of Faculty of Engineering, Professor Udayanga Hemapala, to address this esteemed meeting. Professor Udayanga Hemapala's wisdom and insights has been instrumental in shaping the academic excellence in our university. Ladies and gentlemen, let us warmly welcome Professor Udayanga Hemapala to the stage.
Good evening, all of you, dear presenters and invitees for the MERCon 2023. On behalf of the Faculty of Engineering and as well as the Engineering Research Unit of the Faculty of Engineering, I would like to first thank all the presenters and as well as the people who join online as well as attended this conference as attendees as well. As Professor Buddhika also explained, this event this conference was initiated in 1995 as a local symposium and organized by the same unit, Engineering Research Unit. And then we elevated into a international conference. And over the years, due to the dedications from the ERU and the commitment, of its organizers as well as the academics of the Faculty of Engineering. From 2015 onwards, the symposium converted to a conference, basically international conference. Even though we are getting IEEE sponsorship, it's not only electrical and electronic or computer engineering fields. It's basically now it's converted to a multidisciplinary conference. And Faculty of Engineering, University of Moratuwa always conducts research in all engineering disciplines, as I explained, and it has well established undergraduate as well as postgraduate programs. And mostly we are getting papers, not only from the postgraduate students, actually we are getting papers from the undergraduate students as well, with maybe even without sometimes support as well, like financial supports. These research work mainly sometimes funded or non-funded through diverse mechanisms, like if it is funded like through Senate research grants from the university in the past, and this year also maybe we receive from the SRC some funding, and even we are receiving grants from national research, and as well as main due to the introduction of FGS, actually then we are getting some sponsorship also through the FGS. And but it's this year, due to the financial crisis of the country, we as a university, we know, I mean, we was not ever able to fund like previous years. But with all difficulties, our academics as well as students were able to do research and do publications in various international conferences, not only MERCon. Even since becoming this conference as an international conference, MERCon has been the single most important platform for the University of Moratuwa. Even if you go today, I mean, search through the Scoopers, you can see, I mean, the number of publications has been increased because of MERCon. This is evident through that increase in number of citations as well, and as Professor Buddhik explained, H-index as well. Finally, I wish to convey again my sincere appreciation to the organizing committee of this year, including General Chair, Professor Buddhika Jayasekara, as well as Program Chair, Dr. Sulochana Surya Arachchi, who's the Director of the Engineering Research Unit, as well as all the members of the technical program committees, as well as all reviewers of research papers are also appreciated on behalf of the Faculty of Engineering. Finally, I would like to conclude my speech and invite all the authors, I mean the presenters and participants to our next conference, MERCon 2024, in the next year. Okay, thank you very much.
Thank you, Professor Udayanga Hemapala, for your insightful address and for your unwavering commitment to the Faculty of Engineering and to MERCon 2023. Ladies and gentlemen, it is with great pleasure that I now invite the Dean of the Faculty of Graduate Studies, Senior Professor Ajit D. Alvis, to share his valuable thoughts with us. His guidance has been pivotal in nurturing the intellectual growth of countless scholars. Please join me in extending a warm welcome to Senior Professor Ajit D. Alvis as he addresses this distinguished gathering.
Hi, Boan. Good evening. Yes, another MERCon is coming to an end. I suppose the workshops are there virtually. So it's good to see. I mean, from FTS, you always like to see the international conferences, research, it's happening. And I noted that this session, MERCon had about 138 accepted abstracts and presentations. So hopefully, finally, the conference summary will indicate what exactly transpired. But it's good to note the 138 accepted IEEE, because MERCon has given really an edge to the University of Moratuwa in terms of, because of being a Scopus Index conference. And also you can see from 2015 onwards, climb up in the, because of the papers and cited index articles, University of Moratuwa has seriously, this MERCon has been in the vanguard of delivering that. However, another fact to identify, which I want to stress with researchers and those who have been engaged with, is we have this, we need to translate some of these things into impact. And yes, at this stage with MERCon, we are perhaps the best indexed, the H5 index value conference in Sri Lanka in the Google Scholar Metrics. But its H5 is at 18, right? Now, of course, if you want to benchmark, the Nature is running at 417. So that's the top of the pops in benchmarking. But so we have to look at, and we have to improve on it. So that's what the impacts comes. So just reminding that as we go on doing from conference to conference, but also looking at University of Moratuwa, we have perhaps you may not be aware, though it's in record, it's available on the web. Our strategic management plan includes, we have included a dashboard to really summarize the University of Moratuwa performance, what we called as a 3P metrics, right? 3P stands for papers, patents, and products. And 3P plus P is actually the last P stand for the personnel, mean the researchers. So it indicates how our researchers, how many numbers of researchers are here. We may have a 400 plus staff, but then how many of us are actually engaged in research? We do not have the 100% there. So it's another target is to increase this into from the 50% to about 80% in our quest for ranking going up. But it's important that we look at this 3P and all of us understand this value of 3P. So you publish papers and then you secure intellectual property. I'm pretty sure some of these have the ability to have intellectual property, but we must understand with a little bit more IP awareness that we cannot have abstract submissions and discussions. If we are trying to secure IP, the patent should come first before the publication, right? Something we must understand, but we are continuously been emphasizing this, the publication part, but it's time to understand. We must also look at this, the patenting aspect, because it's the intellectual property and protection of that we can translate or monetize that into some wealth. And at this stage, from a university, we really want to drive wealth by the work that we do. Otherwise, the research per se with the papers, it becomes public knowledge, and that public knowledge gives you value. Now, H5 index 18 means we have 18 papers in the last 5 years have been cited by 18 members, right? So it's been recognized, it's been looked at and been cited in carrying out the other parties with doing their work. But that doesn't give us a monetary return, which is what we can do with the patents. So early days, it was publish or perish. Now today, the mantra is not exactly publish or perish. It is patent and publish. So secure and publish. So it's important as researchers, we do understand the role that we have to play in that. Probably a little less still inside the university and in the country, that when we do work like this, we forget this aspect because we can translate. So it's something that we should see from University of Moratuwa. When you Google, okay, university products that have come out of university system, which are making global waves or the benchmark, I mean, like significant stuff. So we should get excited about when can we put Moratuwa in that map as well, right? So it's very important while we do the research and publish and celebrate with conference, looking at that extra bit, because as a researcher, we can have a bigger value if you think and contribute in that sphere as well. So that is a metric Moratuwa has using in the SMP, the 3P, and of course, the researchers who contribute are of real value. And if you can increase the research output, all the best for the system as well, then that's what we like. So let me wish those, again, as Udayanga mentioned, those who took time to submit, present, and also hopefully this is an event where additional networking takes place, and that may hopefully lead to more research, more collaborative work, and not only confined, because the MERCon, I believe, is not just confined to University of Moratuwa. I was just listening to 3D rendering or archaeological from another university. So this brings in other researchers to the place. And of course, we have the international presence as well. So it's real value, and we must maximize this. So thank you very much for the contribution made to University of Moratuwa. And hopefully we enjoyed, or you enjoyed, doing this research. And after all, the pinnacle and highlight is actually the presentation and meeting the peers with whom you will be discussing, and you see the acceptance in their minds. So best for the current MERCon and completing, and the next one, and just remind in your mind about the 3P as well, as a University of Moratuwa researcher. Thank you.
Thank you, Senior Professor Ajit D. Alvis, for your enlightening address and your continued support for academic excellence. As we celebrate the rich tapestry of academic excellence and innovation, it is our privilege to present to you a glimpse of Sri Lanka's cultural heritage. Through the graceful movements and vibrant colors of traditional dance, we invite you to experience the beauty and rhythm of our island nation. Please sit back, relax, and immerse yourselves in the mesmerizing performance that awaits you. Let the traditional dance transport you to a world of artistry and tradition as we showcase the cultural heritage of Sri Lanka. Without further ado, I present to you our captivating Sri Lanka traditional dance performance. Thank you.
Ladies and gentlemen, I hope you enjoy the beautiful dance performance. Now, I have the pleasure of inviting a distinguished member of our academic community, Dr. Logishan. Dr. Logishan is a local organizing chair of MERCon 2023 and also a senior lecturer of Department of Electrical Engineering, University of Moratuwa. Furthermore, he is an educational chapter chair of IEEE Student Branch, Sri Lanka section. Dr. Logishan, he renewed his own experience and contribution to the field of engineering. We'll be introducing our next keynote speaker. So please join me in welcoming Dr. Logishan.
Ladies and gentlemen, esteemed guests, and tech enthusiasts, it is with great pleasure that I introduce our keynote speaker, Professor Jason Maas. As a distinguished professor of computer science at the University of Michigan, president of Jasaki Labs, and co-founder of MERCon.ai, Professor Maas operates at the nexus of science, technology, and entrepreneurship, driven by a profound mission to create meaningful global impact. Leading the renowned Clarity Lab at the University of Michigan, Professor Maas explores artificial intelligence, large-scale computing system, and programming languages. His notable contributions include pioneering Jasaki, an advanced technology stack, and Jack, a revolutionary programming language. In just 3 years, these innovations have been embraced by platforms like MERCon.ai, TobyLife, and Zero-Shot Bot, elevating the abstraction level for sophisticated software creation powered by generative AI. A serial entrepreneur, Professor Jason Maas has founded successful ventures, including Jasaki Labs, dedicated to leveraging open source innovations in Jasaki to assist businesses in building cutting-edge AI technologies. With a track record of raising over $62 million in venture capital and growing businesses to valuation exceeding $200 million, Professor Maas has received accolades such as being named the 2 most innovative CEO in bank by Bank Innovation in 2017, among other prestigious awards. An accomplished author, Professor Jason Maas has wrote more than 76 peer-reviewed articles. He also contributed to 11 international patents. The best-selling book, Breaking Bots, Inventing a New Voice in the AI Revolution, offering controversial insights on AI progress. Before his tenure at the University of Michigan, Professor Maas made significant contribution to cloud computing at University of California, San Diego, and brought his expertise to industry giants like Google and Intel. With a PhD in computer science from University of Virginia, Professor Maas is a visionary, entrepreneur, and thought leader. Please join me in welcoming him to share his insight with us today. Professor Jason, over to you.
Hi. Can everyone see and hear me?
Yes,
Just nod.
yes.
Okay. Good. Hi. It's an absolute pleasure and delight to be with you virtually from many miles away. But I have to say, I was very struck by the dean's comments on the 3 Ps. I think it's right on. Where we are now, and my talk will touch on some of this. Having impact means something different today than it did 20 years ago. To have impact, especially when it's coming from an engineering science, when it's coming from us, the inventors of the technologies that matter in our lives, having impact almost requires a commercial avenue for manifesting our inventions, right? Publishing alone is becoming less and less the best path to changing the world around us. This in part because there's so many papers and there's so little uptake from the big companies of those papers. It really falls upon us to not only invent, but also take on an entrepreneurial spirit and execute on all 3 of the Ps. So I think you guys have a great leader in that, Dean. And oh man, I can't wait. I'm going to be in Sri Lanka soon, and I look forward to meeting as many of you as possible. But before further ado, let me share my screen and jump right into the talk. Okay, let's just do that and then get I want to make sure I can see you guys while I share on the computer. Okay, cool. Just give me a nod if you can see my screen okay. Yes, good. Thank you. All right, now, we all know about this crazy technology that's changing the world, generative AI. Everyone's talking about it. There's a lot of understanding that we're still doing around this technology. And so my goal in this talk is to provide some perspective from a historical view of tech in computing, how we got to generative AI, what it is exactly, and what it means for how we exert our innovative energy moving forward. So there's a lot that's going to happen in this talk. And for anyone who isn't steeped in the tech underpinnings of this generative AI, at the end of this talk, I hope to make you an expert, or just at least enough to be dangerous. So, all right. So, okay, let's move the slides forward. Okay, cool. Yeah, so I couldn't have asked for a better introduction, so I won't belabor you again with it. I think the important piece is I care about tech, and I've been very active in working with AI in general, and since November 2022, I've been focused on generative AI. So we have 3 goals in the talk. How we got here, because it's a very important story, and it's particularly important because for the first time in our economy, the world has access to participate in the most wealthy industry in the world. Before 1980, you had to be born with a silver spoon in the right place at the right time in order to gain prosperity, right? The industries that were dominating the world was energy. The most money being generated in the world were the oil companies in 1980 and before. Today, the most wealth generating companies are software companies. So if you have access to a keyboard and you know how to run a program, you get to create your own oil. So it's available to everyone. We just have to appreciate that and challenge ourselves to participate. So we're going to talk a little bit about how we got here and what the world looks like from a historical technology perspective. And then we're going to go right into generative AI because it's a fascinating story. Generative AI was not spoken about broadly before November 2022. That's 1 year ago. It's actually a little less than 1 year, a couple of days. We're coming up on the anniversary of generative AI as we know it now in the consciousness of humanity. It feels like it was a long time. But I think the thing I think is interesting to note is how fast we're moving and how much we're moving faster. Okay. And then we'll talk about where it's going. Okay. So this is a slide that I love. I always refresh this every time I give a talk. This slide shows the top market cap companies in the world. Every company's stock is like a currency, and their market capitalization is like their aggregate GDP. These companies are countries, and the wealth being generated by the country. They have $1, and that is their stock price. These are the top ones in the world. And if you notice, it's all tech companies. And mostly it's companies that specialize in software. So the biggest economy driving companies on the planet right now is software and tech. And then some of these companies like NVIDIA, like TSMC down there, are the semiconductor companies that support the running of software and tech. This happened very recently, as you could imagine, because as I like to point out, it's only been 40 years since we had computers. So let's look at that journey. 1980, around 1980, the Apple II and the IBM PC. Before 1980, there was no internet, there was no smartphone, we didn't have screens. That was all sci-fi. It was also unclear whether or not computers would be successful. Remember, Hewlett-Packard passed on the idea of the personal computer and allowed Steve Jobs to just go and do it because they didn't think there was any money in it. Consumer PCs, personal computers, is just this crazy idea, not worth batting an eye to. Very similar to how Yahoo said no to Google, right? However, the idea of the personal computer was in the consciousness of humanity well before it was invented. And we see this in sci-fi movies. Odyssey 2001. We wanted this, and so we manifested it. And in 40 years, our world became this, when there was no concept of internet, and that's only 40 years ago. And then in just 19 years, the concept of the internet came to the fore, and everyone was excited. Folks could see that everything changes now. And that's where we had the .com, .bomb, right? Remember in circa 1999, we invested a bunch of money in the internet. And then all of that popped, right? The venture capitalists in the US here, the folks with the big bucks that were spending it to invest in companies were a little early. And it wasn't until like 5-6 years later that the internet really realized itself. So we had a bomb. This is going to come back because we had a bomb in AI. But what I want you to note is the time compression. 19 years. The world is changing so fast, we're not even noticing it, right? We're just living reactively. But taking that into perspective will let you know what to expect in 5 years, because 5 years is infinite time. I'll convince you of that really shortly. So around 5-6 years later, this is when the internet really realized itself. This is when it actually made sense to invest money in the internet. One of the big two contributions that changed everything. PageRank, the algorithm from Google that organized the internet. Before, it was Yahoo, Alta Vista. Anyone who's more than 25 years old, let's say 30 years old, will know this time. Maybe I'm getting older. It might be 35 years old now. You probably played with Yahoo. This is crazy because I used to love Yahoo. Anyway, Yahoo, you had to actually put in keywords so that you were searchable. In Yahoo, it didn't organize the internet. Google organized the internet, and then we had social media. Facebook launched in 2004. It was niche with MySpace. It was some weird thing. It became common. Social media became what it is now, a assumption that we have in our lives, right? In 2004, these two inventions made the internet a platform to invest in. And that's where we had some of the first major strides in what is running our world economy today. It started around 2005. These software companies rising to the top of our global economy. Amazon also tears out. We figured out how to sell products through the internet, right? Started with books. 2005. That's 5 years later after the internet, 5-6 years later, after the first Netscape internet, right? Internet, 6 years later, Google, social media, our whole society changes. We didn't even have smartphones then. And this was also the perfect storm. I say it's a perfect storm for AI because AI needs three things. It needs heavy processing, lots of data, and then the models are old. They were invented by researchers like you and me in 1970s and 1980s. The core model ideas, neural networks. But it wasn't until this moment when, because we're all living on the internet, we're producing a lot of data. The internet got faster, so images can be there too, right? Lots of images, lots of text, and our computers got faster. With these three things, the first interesting AI bomb, I would argue, experiments were started, right? Google launches ImageNet. Can we have neural networks recognize what's in the picture? 2010. 5 years later, 5 years after social media and we could organize the internet, we had the early AI experiments. Siri came out this year too. So Siri was a very big deal because Siri took an idea that was niche somewhere in some weird corner of the consciousness of the market and made it an expectation. Conversational AI, we can have that anywhere in a consumer product. But this was a bomb because we were all disappointed. Can you set a timer for 10 minutes? That was how advanced the technology is. That's all you could do. What's the weather today? These were the use cases that worked. Everything else failed and left us disappointed. Until, however, much like the internet's the VCs reacted. This is clearly the future. We can do this. Little early again, right? Because it wasn't something we expected to work in our lives. So everything changed around this time. A lot of the science focused on AI in computer science, computer engineering, focused on AI. All of the models we were using, random tree forest, all of these other models, Gaussian mixture models, hidden Markov chains, people stopped looking at those. And they started looking at deep learning because that's what the market showed had promised, though not realized, right? VCs got excited. Then, less than a year ago, we had our iPhone moment, right? In a version of these slides, I talk about the iPhone because before the iPhone, there was the Palm Pilot and there was the BlackBerry. And then there was the iPhone moment. This is a trend. We always have early versions of tech that don't work. And then you have a moment where everything changes. It happened here with ChatGPT, right? Indeed, I was teaching about generative AI before ChatGPT launched. I have a class I created called Conversational AI, Principles and Practice. And we talked about transformers and generative AI. But it was niche. Generative AI was niche until it was proved and it was something we can integrate in our lives and use, and it changed everything. So that happened less than a year ago. So what happened in a year? Let's look at this time compression. Everything's happening every 5 years. Every 5 years, something changes. The world changes every 5 years, right? What's going to happen in the next 5 years? I don't know. But we know what happened 1 year ago. What happened in that 1 year? Well, in this time period, all of these companies are now describing themselves as AI companies and investing mostly in being competitive in that realm. So AI is here to stay. It's not a fad, right? It's not a hype cycle. Don't listen to the business folks. They have their hype cycle theory to everything. And it's kind of is an interesting way for them to like seem very credible. Well, oh yeah, we're in a hype cycle and there's gonna be a cooling. Not with AI. This is not the 3D television. If anyone remembers 3D television. or VR, virtual reality. Actually, virtual reality is we haven't had our .com, but explosion in virtual reality yet. Let's see what Meta does. Anyway, I digress. So AI is what's driving our economy, and indeed, NVIDIA is number 6 because of AI. Right? It's not video games. The original reason we invented GPUs is graphics. So that's not really why it's number 6. It's number 6 because the world needs to run AI. Okay, cool. Let's look at what happened in a year's time. Indeed, let's observe. I've never seen anything like this in the market. We're going to look at how VCs are spending their money, right? These are the bets that the folks that fueled these companies, the same folks that recognize, put the money in to your Googles and your Facebooks and all these things. Where are they putting their money today? I've never seen anything like this, right? Because this graph here shows the capital invested in generative AI or in AI in general 6 months after ChatGPT came to the fore. So this ends at June, right? So this is old data. This is June. So half of the year in, they put $14 billion in generative AI companies. That's fast. And the market itself was a conservative, bearish market in VC land post-COVID. Post-COVID, all the VC money kind of dried up, yet they made an incredible amount of investments in generative AI. 6 months. This is in June, right? So this is probably double that number or higher today, because we're in November already. It's crazy. And these are the top venture capital investors in the world, right? Inside Sequoia, Andreessen Horowitz. I don't know if you guys have heard of some of these folks, but these are the big ones. These are the folks that funded Google and Facebook and Microsoft and Apple and all of those, right? They're investing in these companies today. Where's the money going? Remember, this is only 6 months in. So on the graph to the right here, one thing I want to highlight is a lot of the money is going into the infrastructure. That's actually the safest bet right now. The safest bet is, okay, we know generative AI is going to be a big deal. We don't know what the experiences will be like. We don't know what the products will look like. Indeed, when they're making the decisions to put that $14 billion in, they have no idea like what is going to be the sticky things that we as a market will pay money for when it comes to this technology. So the industry-specific generative AI applications investments is smaller. That's the point I'm making. And the safer generative AI infrastructure, that's the models themselves and the infrastructure to support APIs so you can hit a model, is where a lot of the early money goes in. But what will happen is in 1 year or 2, this graph is going to be skewed towards the applications, because the applications is really what matters. And there's a couple reasons it'll be skewed. One of the big reasons, and I have a slide for this, is VCs don't understand tech. You know what I mean? Like they don't understand how democratized this generative AI is in actuality today. Anyone can have it. Indeed, I'm working with some really bright people from Sri Lanka who I've been incredibly proud and delighted with my collaboration with University of Moratuwa, Logi, and some of the talented students I've been able to engage with. And I have some students looking at how do we make these models small enough that we can put it in our own computer and have GPT-4 chat GPT level experiences customized to whatever we want, right? The technology is democratized. We'll see. But that's why the infrastructure isn't going to be so interesting. It's going to be the applications that become very interesting. It's going to be, the iPhones, right? Not the screen company that produces the screen for the iPhone, right? That you want to invest in. So that's what's going to happen. That's a natural evolution with early technology when you have conservative VCs. Anyway, so there's a lot of very fascinating information as to what's happening in the market. But I think what we should talk about next is what is it? What's the underpinnings of it, right? One thing I want to point out, and I can't understate, is the rate of progress of our species, right? So this is a graph that shows human population over time. And I've noted when certain things were invented, right? Computers, 1980, internet, 20 years later. At the scale of time, it's breathtaking. And so it's a wonderful time. It's a wonderful time to be observing our world and how it will change. You know, what's going to happen in the next 5 years, and what's your role in that? What's your role in creating that, right? Generative AI and AI happened around the same time. It's very interesting, right? All right, so what exactly is this tech, right? And one of the promises I made is you're going to understand exactly where it came from and what it is fundamentally. So this is what generative AI is. Before last year, that orange box didn't exist in this slide. So artificial intelligence is a broad category of technologies that are computers pretending to be smart. That's it. It can be an if statement. You can call that AI. Machine learning is the class of models that learn from data. That's it. If you're using data and patterns in data, existing real data to get a model to know how to make predictions, that's machine learning. It doesn't have to be neural networks. It can be a regression model. You train a regression model with data, with features, and then that model can make predictions with new data, right? Deep learning is the class of models that learn from data that mimics the biological neuron, and many of them. And then generative AI is a class of these, which today, generative AI broadly means models that once they learn will, in the scope of large language models like ChatGPT, it's looking at some input and it's generating word by word what to say next. These models aren't thinking in a traditional sense that, or in a way that we would think that we think. I had a debate once as to, do we think like an LLM? And I was like, of course not. We don't think one word at a time. But do I actually know what my brain is doing? I don't know. Maybe each word I say really is an automatic firing that is based on the previous words I've said. You know, I don't think when I speak in that way, word by word. So I can't even say that I don't work like a generative AI, but it's a class of models that are neural networks that will generate or predict what word to say piece by piece, right? And I'll really give this talk in the context of large language models. You also have stable diffusion models, which I'm happy to give a talk about too, but I'll focus on generative AI in the context of LLMs. So most of you know this, right? That there was an experiment not in computer science, not in engineering, where we tried to understand whether or not neurons can learn new things that are outside of the class of things they were evolved to. So this is a Skinner box, and it's an experiment where they try to train pigeons to recognize the difference between Van Gogh and Chagall paintings. And the pigeons were able to recognize it with a 95% accuracy, the difference. They could probably do better than I could if you trained me with treats. So this was happening in cognitive science, neuroscience realm. What do computer scientists do? Well, of course. We're like, oh, is that how knowledge works? Let's simulate it in a computer, right? So they took some of the principles that comes from biological sciences around neurology, and given what we know about the neuron, deep learning really is a simulation of a neural network. It's a math formula that takes in inputs and produces a signal strength out. These are neurons that fire, simulated in math. It's absolutely fascinating. On the bottom, you're going to see the evolution that got us to generative AI, right? So this was really, we're early on, right, in that evolutionary journey toward generative AI. And this This happened in the 80s. And then we figured out how to make this kind of machinery do better than humans. This model, it's actually an old model as well. We discovered as a species that, oh, these models can do better than humans. Like when looking at written digits, sometimes if the handwriting isn't good, we can't figure it out. It turns out that this neural network can do better than us at figuring out a handwritten digit, right? So this is the early stages of deep learning. And then the next big step was to take the same machinery. We're just training these simulated math formulas to fire at different strengths. And we discovered something called self-supervision. And we accidentally, and this is the thing that really a lot of folks don't understand about the AI, the way science is working in AI. We accidentally discovered the notion of pre-training. Pre-training was an accident, that you can train a model with a self-supervised task, and then it knows how to do new things, right? So you take this model, the self-supervised task is, let's say, read Wikipedia and predict the next word. This is a simplification, right? It's doing a continuous bag of words technique in this particular model that's predicting the middle word. Doesn't matter. But we're just having it predict the words in the sequence as it appears in Wikipedia. That's all. There's no task. There's no, well, tell me what the digit is. There's no like downstream like task of, tell me if the sentiment is good or bad, happy or sad, or what the topic is. There's no real instruction to the model other than just predict the next word and learn what you can. Get good at that. And the idea was, if the model can get good at predicting the next word, it has to learn something about language. And then in the paper itself, they say, oh, they had a happy accident. Oops, this is amazing. I don't know what it means. And this is actually the happy accident that happened in 2012 that set us on an unstoppable train that ended in generative AI as we know it today. This is the beginning of an unstoppable, inevitable train. Because once we had it read Wikipedia, it was able to do amazing new things, such as you can ask this model, if you have a king and you took away the man of the king and you added a woman, so a king minus man plus woman, what is that? The model will tell you it's a queen. So what does that mean? Does the model understand what it means, the meaning of what it is to be a man and the meaning of what it is to be a woman and what a king is and that kings are men and queens are women? Does the model understand all of that? All it did was read Wikipedia, and the authors were like, we never expected this result. We were amazed. I don't know why it worked like this, but it worked. That means the model has to know something about what it means to be a man. It has to, right? It's provably the case that there's some kind of knowledge distilled in those weights of that model, where after it read Wikipedia, and you articulate through its language, king, what is a king minus a man plus a woman? And it'll tell you queen. It knows something about the world. That was a happy accident. And this generalized to other types of tasks. Spain is to Madrid as Italy is to what? And it will tell you Rome. So it knows something about capitals. It knows something. We don't really understand what, because all we did was tell the model to read. And this happy accident in 2012 changed natural language processing as we know it and set us on the train. That's the first big discovery. Then, 2 years, 3 years later, everybody's working on this. Like, what does it mean? How do we do better? How do we get it to do more stuff? That's what we researchers do. And there's 10,000 papers in every conference in AI these days, every year. So just a few years later, Google. So there's Google on this slide. Google did this one too. But Google was like, you know what? We want to make these models a little bigger. We want to make them smarter. We love this pre-training stuff. We could just tell it to read stuff. This is really interesting. What can these models do? And then Google invented the transformer. Why did they invent the transformer? Because you can train it in parallel. Shortly after this model, which is essentially the standard neural network, feed-forward neural network it's called, applied to text, folks started working on a new kind of neural network that takes into account the sequences of the words. Because it turns out that the sequence of cheeseburger with ketchup or no cheeseburger, cheeseburger with no ketchup and no cheeseburger with ketchup is different, right? But you have to, the sequence of words really, really define the meaning, is the point. And those kinds of models are called recurrent neural networks. They're slow. Those are slow models to mess with. So Google invented a transformer because you can train it with GPUs and you can get sequence. The dependency between words could be represented in the model. The transformer neural network. This came from that other discovery, that happy accident. We were like, oh, let's make it bigger and faster. And then we had transformers. And then we were at the next phase. And then we said, you know what? We kind of have the compute at Google and such to like use the internet this time. We're not going to use the Wikipedia and Google News. We're going to use like a subset of the internet. And it turns out that it got smarter. Now, Google's experimenting. They're inventing all this stuff. They invented all of this. And then OpenAI asked the question, what if we made it really, really big? What'll happen? And like let it train for a long time. Indeed, what if we took $4 million of compute time and just let it run? Is there limits to what it can learn? It can learn man minus woman equals queen and other things. We're doing better and better every year. A couple of years later, from 2012, we just made it big. OpenAI did this with GPT-3, the first product. Microsoft spent $1 billion for this. And it was amazing. Things were still niche. And then around a year or two later, after this work, which folks weren't really paying attention to generative AI, we had GPT-3 and ChatGPT. We had ChatGPT. And ChatGPT, it's actually a phenomenal contribution. I just have to get a little technical here. There's this technique called human feedback reinforcement learning, where you can train a model to judge and score quality. So what they did here with ChatGPT is they took ChatGPT-3, the same thing. It was actually really amazing, but you couldn't talk to it like a human, like we do with ChatGPT. They took ChatGPT-3, made a copy, and then trained the copy to judge quality of response. So they created a special data set to train that copy that already knows a bunch about the world. It knows what a man is, what a woman is, queen, all that stuff. And then we're going to train it to judge the responses of another model. And then we're going to let these models train each other. Reinforcement learning. First time reinforcement learning really shines in a practical application. I mean, things like AlphaGo and so forth, I'd argue is not practical. There's no products, there's no invention that will change our lives. But this was an application of reinforcement learning that actually did change our life. It's the first I'm aware of, right? That's not a video game playing itself. Anyway, so one model's training another model for as long as you want to run it, right? And that approach, that methodology is what gave us ChatGPT. And that was a year ago, and the world changed, right? So now you understand. Now there's a lot to this story. This is how OpenAI eats Google's lunch. I don't know if you guys follow it like as a nerd like I do. The talk, Google had an emergency talk after GPT came out. In this emergency talk, all they said was, we're coming out with Bard. Bard's coming. We have our own thing. And we invented the transformer. This is our tech. We invented all this stuff and we got Bard coming. Is Bard as good? No, man. I could talk about that too. It's because institutional knowledge and know-how in AI, nobody understands how it works. It really is an artisan science when it comes to making models do good things in practice. Is an artisan science because we don't actually, there's no rules. It's like, you're like, oh, if I make my data like this and I put it in like that, then it produces that. It's a very artisan science. And so Google just wasn't in practice. So that's why Bard isn't as good, even though it's bigger. Anyway, so ChatGPT is here. And Microsoft spent $10 billion. There was a time, and this all happened in a year, guys. So Microsoft closed a $10 billion deal with OpenAI to have exclusive rights to monetize their infrastructure, right? So every time you pay OpenAI, you're actually paying Microsoft a little bit because everything runs in Azure. It's a very big deal, and it covers all their models. The new DALL-E thing, that's all actually running in Azure. It's all complicated, but I thought it was very savvy at the time. But now I'm not so sure. Why did I think it's savvy? I thought it was a savvy move because to have exclusive rights on OpenAI with the theory, with the thesis, with the assumption that OpenAI is going to own this tech and we will all be using these GPT models that are very expensive to train. It's smart because then you have 100% ownership of it. However, this is the world we live in. I don't know if you guys have seen this picture before, but OpenAI is on the left-hand branches of the right tree. This shows the evolution of models from the transformer era. So you'll see BERT on the left with Google. The shaded in boxes are open source models. That means you can download these and run them. The closed source models are not filled in bubbles. So you can see there's a large open source ecosystem. And you can see where ChatGPT fits in this evolutionary timeline across time. And Llama 2 is open source and free. That means you can run Llama 2 on your computer and it works as good as OpenAI's ChatGPT 4. That happened in a year, within the year. So we have Llama 2. Thank goodness these guys publish all the results, right? Because this human feedback reinforcement learning was published and just shared freely in a year's time. Everybody's copying it. Meta, with their Llama 2, threw a bunch of computers at training their own, made it open source. There's Mistral, there's Zephyr. These things report to beat OpenAI's GPT-4 and be much smaller. And so this technology is being democratized. At the same time, NVIDIA is working on chips that can run them better in your machine. So you don't need to have these $40,000 machines in order to, like 6 of them, in order to train one of these things, right? There's techniques and science coming out about how to train them in a parameter efficient way, which means much less compute to get the models to be super smart at what you want it to be. And so in a year's time, that's what everyone's working on. And because it's in the forefront of technology accepted by the world market consciousness, everybody's working on this stuff. Okay, so what now? What does this mean? What does it mean for you? What does it mean for me? What does it mean for us, right? Well, this is happening. And it behooves us to embrace it because we are in a competitive world, right? So this is a very unique tool. This is unlike any other thing. You know, people always say, oh, well, you know, when we had the automobile, society changed. When we had, the cotton gin, these industrial machines, you didn't have to farm the same way. You could use the machinery to accelerate your productivity. This one's wild, right? Because you essentially can hire a very knowledgeable best friend for like pennies a day. that can help you through everything. So understanding how to wield this tech is going to be important. And we should engage because this is going to be running the world. And so I have some homework for you. The homework is to read this blog article. This blog article shows you some of how to talk to LLMs to get it to help you in just the right way and give you very useful output. So this applies to everyone. This is what everybody should do. Everybody should be using LLMs like you use email. Everyone. You should never have a question that goes unanswered. You should never not how to know something. Have the LLM teach you. If you haven't used ChatGPT, use it tomorrow and let it teach you something complex. And you have access to knowledge that's beyond anything we've had before, and it can do work for you, right? It's like having 100 employees at your disposal. It really is. If you learn how to wield it, you get 100 employees, right? Now, what should us researchers do? We have to re-envision the future because this is the personal computer. This is the internet. This is going to become ubiquitous and table stakes, right? And the faster that you participate in understanding how this technology changes what we do, the better. So folks are already re-envisioning. So we know how to have like a new web search that's now an AI, right? You can get information, learn stuff from an AI. But that's the tip of the iceberg. We could also envision AI acting on our behalf. It's not, we have the technology today to create an AI that reads your email and writes responses for all of your email. And you can just hit send, right? Like the tech is there for that. I was telling my buddy that there's tech where you can have an AI read your source code and recommend commits, recommend changes to make to add features and make those changes. And you just have to accept. Like we have the tech for that. AIs can act on our behalf. They can reach out to a friend that you haven't reached out to in a long time to try to reconnect. And you just have to say, hey, reach out to my old friends, see if we could reconnect. And it can say relevant, interesting things. Like these kinds of applications, AI acting on our behalf is coming. Let's understand that. We also have to understand how we command computers and technology. Right now, we have deterministic ways of doing it. We write a program. The program is logical and it's algorithmic. Every step is determined by the programmer. But how do we code with AI? How do we let the AI help us? So how do you articulate instructions to a computer that are not deterministic all the time, that can be inference-based? These are very recent papers, 2023. And this is at PLDI. We're already reinventing how programming languages are designed and implemented, at least in the academic sphere. At some point, that's going to hit the way we live and work, right? Although in the PL world, translation is much slower for some reason. Anyway, the most important graph I want to show everyone is just to look at what the heck is happening in our world, in our life, and for our species. This graph shows hourly compensation as it relates to productivity from 1960s to 2020 or whatever, right? The compensation used to be one-to-one congruent with the productivity. So the more people work, the more people got paid, right? That was a thing. Isn't that an interesting point when things started to split, where the compensation started to flatten? It didn't go up as much, but productivity kept growing. What happened at that moment? Does anyone remember? Can anyone remember? Did anyone take a gander? I'm just drawing these observations, right? I'm just connecting the dots here. Around 1980, what happened that was a big deal? Computers, guys. Isn't that interesting? The point where that division started, it's really at the inception of the computer. And it continues. And then we had internet. And then it's almost a natural evolutionary thing with technology. We're finding ways, and I love this about our species. Our species is fundamentally lazy. We want to build machines that does work for us, that generates productivity in our stead. That's what we aim to do. That's our dream. If you want to start a startup, understand what your startup does in relation to that fundamental human aspiration to be lazy. You know what I mean? Anyway. But what happens now? Well, I think we have to prepare for a world that looks like this, right? We're getting really good at this thing. And this is wild, right? Because our species is 12,000 years old. The modern kind of society, of course, we're millions of years. We're like 400,000 years old as a genetic species, but as a farming and industrialized species, we're about 12,000 years old. And only yesterday, we discovered how to be productive and not work. And we're getting really good at it. So what does this world look like? I believe this world looks like universal basic income. I have a whole public policy talk around this. Like what should we prepare for in society given this trend? And this is going to happen in our lifetime because look how fast we're moving. 1980, 2000, 2010, 2015, 2023. We're moving at breakneck speeds with this technology, and look at what's happening in our world. Productivity is increasing, hourly compensation is stagnated. We're going to need universal basic income. We're going to need a society designed without the assumption that everybody works. Like we're going to have to do that, right? And that's going to come. I mean, and we're going to live through it given the rate at which we're progressing. So this is food for thought as to what's happening. And I will substantiate this. My evidence that everything I've said so far matters is that graph, is that one chart with market capitalization, right? That matters. And this is this is behind the scenes why we have the top 15 currencies on the planet is software companies, and it's going to be AI companies. Like they all are reinventing themselves to be AI companies, and that happened in the blink of an eye. Okay. This disruption is different though. Like I talk about it as this technology that advances we have to adjust. Like everybody you hear talk about this stuff will say, oh, well, it's like when we invented the automobiles, of course, society will change. Some jobs will go away. That's the popular opinion. I have a different opinion. I think this is very unlike any other technology. And here's why. We are living most of our existence online. See, not a lot of folks are talking about this, but our money's digital. The way we feel, the digital experiences we have controls how we feel more these days than our actual interactions in the real world. All of my students don't come to class. Like since COVID, 5% come to the classroom. Everybody else is watching from home in their bed. We go on social media. We live online. Plus, with AI, we can't tell what's real. So our information is coming through a screen. And with this disruption, we don't know what's real and what's not. So this is a picture of the Pope. This picture does not exist. Pope has never worn a, very hip hop looking coat. You know what I mean? This was generated with AI. And if you look around the world, you'll see we've got Obama's voice being spoken speech to text. You know, you've got images you can't even tell. You can't tell where a blog article came these days. It could be written by ChatGPT. Today, less than a year after we had the tech, 1 year, we can't tell where things came from. So this is messing with our notion of reality. This is different. This is not just technology that advances us. This literally is technology, and I'm going to say it, that replaces us in the digital realm. It already replaces us in the digital realm. And we can't tell whether it came from a human or an AI in the digital realm. So we have to be thoughtful on how we engage this. And it's so early. It's like the discovery of electricity. It's like, except we're moving faster and the whole world's working on it at the same time. It's crazy. Anyway, just to mention a little bit about what I'm doing. You know, I'm on sabbatical right now. I'm deeply engaged with University of Maratura. I'm teaching a seminar course right now, a research course around generative AI and how we envision that future. Logi's been huge. He's been my key point of contact and a great companion and colleague along the way. I work very closely with my postdoc, Yiping Kong, and my collaborator, Lingjia Tang at University of Michigan on this Jiseki endeavor. And at this stage, it's really about creating open source and free tools to allow everyone to participate in the revolution. The whole goal of this project is to enable folks, all folks, to be able to build amazing AI research and products. You know, there's a couple companies that I work closely with. There's Mica, which is an AI for productivity, Mica.ai, and coming soon it'll be Tobu Life, which is going to be an AI that sits on your shoulder and remembers all your memories with you. As you take pictures, you can talk to it with conversationally, and it'll just remember and chat with you forever about your photos. So that's another interesting project. And with that, that piques my interest. And with that, happy to take questions. You know, you feel free to reach out to me anytime. I'm always happy to meet new folks that are curious and that might want to collaborate on an interesting project. So with that, thank you so much. Yeah, any questions? Thank you.
Hello, Professor Mas. It's a very nice talk on the generative AI and the ChatGPT and all the things. So yeah, you have short about the transformers and basically, yeah, so the GANs now we have stable diffusion. So the one of the issues we have at the moment is the ethical aspects of the deep learning or the generative AI. And also, for example, if we consider them writing to a paper to a top conference, and also in reviewing, they ask about the ethical aspects, the bias and the explainability. So what is your view on these aspects and how it will change? And yeah. That's my question.
Yeah, that's a phenomenal question. That's a very good question. So, well, look, at the end of the day, the models, as we have so far, has learned bias from the data that it sees, right? And there's actually a lot of that stuff that gets, you know, if you haven't read Unbounded Internet, of course, it's going to learn biases in every place. I think the best way that we address this is to allow the models to be exposed to all information and learn itself about bias. It needs to develop an awareness about what bias is. So there's two approaches, right? There's two approaches. Let's say, and I would call the first one the naive approach, and then the second one harder, but probably the right approach. The naive approach is to make sure you control the data that the model sees. I never want this model to see anything bad or biased. I want all of the data to be unbiased, clean, pristine, so the model never learns bias. That's approach one. That's what a lot of folks do. Or you want to train the bias out. You want to train it to never say anything bad after it saw the bad stuff. So that's approach number one. That has problems, right? And approach number two would be, let it be exposed to all of it, and let it also understand more deeply. We are exposed to bias all the time in our lives, but we know how to transcend that because we're self-aware about it, and we know when it's harmful and why it's harmful and why we shouldn't act in that way and so forth. And so we need to take the training to that level. Indeed, it's like raising a kid. This is a very tough one, right? Should you let your kids be exposed to, like bad stuff, or should you keep them completely insulated from bad stuff their whole life and hope for the best, right? So I think it's similar, right? It's almost like you want them to see the bad stuff, but also understand deeply why it's bad and the principles of how to be a good citizen. So I think that's actually ultimately the approach. Now, how to do that is I don't know how. It's easier to try to prevent it from seeing the bad stuff. I agree. And so you'll see a lot of that happening. And OpenAI actually trains it to forget the bad stuff using that reinforcement learning. But I think ultimately long-term, that's where we're going to need to take it. Because I don't know. I don't really like talking to a model that I know has been sanitized. You know what I mean? But you also don't want the model to cause problems with that bias. So I think those are the methodologies to investigate. How do we train models to be resilient to biased data and understanding of how to kind of mitigate the negative implications of that bias, I think is the right approach. Good question.
Thank you so much.
Yeah.
Thank you. An inspiring answer. I also have a question about the knowledge that NLP models have. Now, I thought that these have second-hand knowledge. That means what human beings thought about the world, they wrote on Wikipedia and every other place, and they learn from this second-hand knowledge. How can a model truly understand the world and build a world model?
So here's an interesting, I agree with you, and I like that point, but here's an interesting question. Do we learn about the world through secondhand knowledge? Much of what we
touch and see, look at things,
Yeah. I know what you mean.
Jump into the water, drown and see, experience that you drown in the water, things like that.
Yeah. This is a very interesting question, and it's such a good. It's almost it borders on philosophical, right? That question. Like, here's the interesting thing: neural networks. Our knowledge and our ability to navigate this world has so much more than the simulated neurons have. For instance, we have dopamine systems. We have neurochemistry. The neurochemistry is not modeled in these systems, right? And actually, a lot of our learning comes from how we feel about an experience. Oh, I got bit once by that, whatever mosquito. I really don't like mosquitoes. That's a very different kind of knowledge that these models can't have. So fundamentally, it's always going to be different. But because I can't answer that question, but I will give you, because it's a deep one, but I will give you an analogy that I found helpful for this kind of question. So I have a colleague, Kunle, at Stanford. He always says, look, when we invented airplanes, we took inspiration from birds, but we didn't model it 100% accurately. Like, we don't have planes that flap their wings, but we do take advantage of the aerodynamics of how wings function in the design of the airplane. So though it was inspired by birds, it doesn't work like a bird, and it probably can't. It probably would be not wise to try to bring it more in alignment to birds because of the difference of that environment. And so perhaps that applies to neural networks, right? Like, I don't know if we should get really good at neural networks being able to model fear or anger or elation or these things. I don't know if that helps its utility for our purposes. But it's you ask a very deep and philosophical question, like can models learn through that kind of experiential thing? I don't think they can. I don't think we will touch on that for a very long time. Yeah.
Thank you. Thank you. Makes sense.
Yeah. Yeah. Yeah.
Thank you, Professor Jason Mars, for your wonderful keynote speech. We are so inspired by your delightful thoughts. We appreciate your valuable presence, and also we are truly privileged to have such esteemed personalities here with us today. Also, we are so excited for you to meet us soon in Sri Lanka. For your contribution in MERCon 2023, we have prepared a token of appreciation for you, and we are looking forward to give you when you are soon with us today.
Thank you so much. Thank you so much. I greatly appreciate it. I will come to pick that up myself. I will be there. So.
Thank you, Professor. With that, ladies and gentlemen, after 2 days filled with innovation, collaboration, and insightful discussions, we now turn our attention to the grand finale of MERCon 2023, the awards ceremony. As we gather here under the brilliance of ideas, let the excitement in the room rise as we prepare to honor the trailblazers who have left an indelible mark in their respective fields. But before we unveil the winners, let us reflect on the inspiring words shared throughout the day. We've had speeches that ignited our passion, discussions that expanded our horizons, and a keynote address that challenged us to reach new heights. Now, imagine this stage as a theater of achievement, where each track is a distinct act in our collective journey. The curtains are about to rise, revealing the stars of MERCon 2023. From the intricate dance of mechanical engineering systems to the electrifying performance of power systems and the symphony of big data, machine learning, and cloud computing, the stage is set for a dramatic unveiling of brilliance. So without further delay, let the spotlight shine on the first act of awards of our award ceremony for MERCon 2023. But before that, let me call Dr. J.R. Gamage on stage to brief us about the selection criteria for the Best Paper Award on behalf of the Awards Committee of MERCon 2023. Dr. J.R. Gamage is a senior lecturer at the Department of Mechanical Engineering, University of Moratuwa. Please join me in welcoming Dr. J.R. Gamage.
Very good evening, ladies and gentlemen. Varuna has to leave for family urgency. So I got the job on the spot. So I took up the explanation of the selection criteria for the Best Paper Awards. So the papers nominated based on the review scores through EDAS. So we normally assign more than three reviewers, and the average review score is considered. And the paper selection per track is based on nominate best three papers. That means best three papers were nominated with tracks with less than nine or less than papers. And the tracks with more than 9 papers, there were 5 best papers nominated. Tracks with more than 9 papers, 5 best paper nominations were done. And for any track to have at least any of the nomination, that track should have more than 3 papers. So that was the criteria for selecting best papers. And the presentation of the nominated papers are evaluated by the award committee members for each track. And the total score has been calculated by 60% from the paper review score and the balance 40% from the score received during the presentation at the sessions. 60% from the paper review score and 40% from the score received during the presentation. So I'd like to mention the award committee members. I'm representing them, Dr. Varuna Adhikariwatta, Professor Ruwan Gopura, and Dr. Lihil Subasinghe. I wish good luck to all the best paper award winners, and I hand the control back to the compeer. Thank you very much.
Thank you, sir. So, without further ado, let's start our awarding ceremony. So, to hand over the certificates, I invite Professor Ajit Alvis, Dean of Faculty of Graduate Studies and also Senior Professor of Department of Chemical and Processing Engineering. So, please come to the seat. Let's start with our first track. It's robotic and intelligent automated systems. This award goes to Hausararaj Rajendran, H.M. Ravindra Taraka Bandara, Buddhika Prabhat Jayasekara, Chandima Deduwa Patirana, and Chamil U.S. Surya. This is for user profiling based proactive interaction manager for adaptive human robot interaction.
Now to present the award in the second track, in the track of material science and engineering. The best paper is awarded to Lochana Samaravira, Loku Tota Hevage Pasindu Buddhima, Sudarman Upali Adhikari, and Chamiru U.S. Surya for the paper titling Modeling and Simulation of Nanogenerator using Vertically Integrated Zinc Oxide Nanowire Array.
Thank you, Professor. Now, I invite Professor Ruwan Gopura, Head of Medical Technology in Faculty of Medicine, University of Moratuwa, and also Professor of the Department of Mechanical Engineering. Please. This is our third track. It is textile and apparel. This award goes to Dilshan P. Hedigala, Malindu Ahal Gastenna, Indrajit D. Nisanka, Ranjit Amarasinghe, and Gayani K. Nandasiri. This title is Computer Analysis of Artificial Neural Network and Multiple Linear Regression Models in Predicting Pressure Transmission of Pneumatic Actuator used for actual compression.
The next award is in the track of mechanical engineering systems. And the best paper award in this track goes to Pasan Henadira, Chamara Somaratna, Venusara Satyakshana, Johan Vitanage, Nalaka Samarvira, and GPR Chandima for the best paper titled Ultra Low Thermal Conductivity of Laterally Arranged Nanowire Arrays through Construction Engineering.
Thank you, Professor. Next, I invite Mr. Dhammika Marasinghe, IEEE Sri Lanka Section Vice Chair. This is our PIPS track, and this is Power Systems, Electrical Machines, and High Voltage Engineering. This award goes to Nadira Dilshani Premadasa, Rusita Sanjay Silva, Chandima Deduwa Patirana, Karunadasa JP, and JMASS Jayasundara. This title is Optimal Sizing of Solar Photovoltaics and Battery Storage for Domestic Prosumers using Genetic Algorithm.
The next award is presented in the track Big Data, Machine Learning, and Cloud Computing, and it's awarded to Gayani K. Sirivardhana, Hashini D. Jayawardhana, Varuna U. Bandara, Saman Atapattu, Vijita R. Hera, and Aravind for the best paper titled Federated Learning for Improved Automatic Modulation Classification, Data Heterogeneity, and Low SNR Accuracy.
Thank you, sir. Ladies and gentlemen, this moment is honor to the true champions of MERCon 2023. It's our sponsors. Let's roll the tape and express our heartfelt gratitude for their unwavering support. Here's the visionaries who make this dream reality. Enjoy the MERCon 2023, the sponsor tribute video.
Preserve its beauty while surrounding yourself in the transcendent aesthetics of your dreams. Embrace a world of elegance and sustainability with Swisstech Aluminium. Swisstech Aluminium. Live in elegance.
Canon, delighting you always.
This event would not be possible without our sponsors. And ladies and gentlemen, let's give a hand of applause for our sponsors. That being said, let us move to the next set of awards. And to present the next set of awards, I would like to cordially invite Professor Buddhika Jayasekara, the General Chair of MERCon 2023, who is also the Chair of IEEE Sri Lanka section and also a professor in the Department of Electrical Engineering. Sir, please join us on stage. The next award is in the track of Chemical and Process Engineering. The best paper goes to the paper titled Utilization of Pre-Gelatinized Lesser Yam Flour to Formulate Coconut Milk Powder, and it's presented to G. Kiyanage Dona Sanduni Umayangani, Ayesha Sanduruvani, Mayumi Silva, and VKDM Akmal.
And then we have another track. It's transport and logistics. For that, we have an interesting title, Enhancing the Existing Benefit of Robotic Process Automation in the Logistics Industry. In this title, the award goes to Heva Kaduweduwage, Sandunu Prabodha, Harishani Liyanage, and Hashini Ratnayaka.
Thank you, Professor. To give away the next set of awards, I cordially invite Professor Shanta Egodage, the head of Department of Chemical and Process Engineering. And along with that, I'd also like to cordially invite Mr. Nilhan Niles, head of Department of Textiles and Apparel Engineering. The next paper is awarded in the track of Sustainable Energy and Environment. And the best paper award goes to the paper titled Development of AI-based Optimum Energy Resource Management System for Prosumers with Solar Rooftops. And it's presented to Hiroshi Nilupili Veerasekara, Pavitra Kasun Vella Arachi, Savin Ranganathan, Asanka S. Rodrigo, and MKD Aponso.
And then we have the track of Constructional Engineering and Risk Management. This title is Indoor Overheating and Well-being in Elders in Tropics, and analysis of thermal comfort and skin temperature profiles. So the word goes to Mohammad Sajjad, Indika Rajapaksha, Chandana Sirivardhana, and Tharindu Udagedara.
Thank you, professors. To give the next set of awards, I would like to cordially invite Dr. Ranga Rodrigo, Head of the Department of Electronics and Telecommunication Engineering. And alongside him, I'd also like to invite Dr. Indrajit Nisankar, the Senior Lecturer at the Department of Mechanical Engineering. The next best paper is in the track of Mining and Earth Resource Engineering. The best paper award goes to the paper titled Google Earth Engine-Based Assessment of Seasonal Spatial Distribution of Water Hyacinth in North Bolgoda Lake, Sri Lanka. And it's presented to Asita Radampola, Hirusha Sulakkana Davalagala, Francis Gousigan, Sandun M. Dasanayaka, Chulanta Jayawardana, Samarasuriya Patabandiye Chaminda, and Irushika Maheshi.
So, as our next track, communication signal processing, the best paper award is for Minimax design of MD complex coefficient FIR filters with nearly constant log group delays. And this award goes to Darukishan Perkiraj, Chamira US Edusuriya, Chamit K. Vijayanayaka, Arjuna Madanayaka, and Ashani Piyatige.
Thank you, professors. To give the next set of awards, I'd like to cordially invite Dr. J.R. Gamage, a lecturer in the Mechanical Engineering Department, and also Dr. Chamira Edusuriya, Senior Lecturer at the Electronic and Telecommunication Engineering Department. The next best paper award is in the track of Structural Engineering and Building Materials. And the best paper award goes to the paper titled A Field-Validated Numerical Prediction Model for Railway-Induced Ground-Borne Vibrations. And it is presented to Fapetha Tadasona Murthy, Hasita Damruwan Hidallana Gamage, Chamindalal Sujiva Levan Gamage, and Rusiru Sanjaya.
As for the next track, we have Hydraulic and Environmental Engineering. And the best paper award goes to Rating Performance of Global Climate, Models in Capturing Monsoon Rainfall Patterns in Sri Lanka. And this award goes to Chamal Jayaminda, Luminda Gunawardana, R.L.H.L. Rajapaksha, and Chamini Disanayaka.
All right, thank you, sir. And to present the final set of awards, I cordially invite Dr. Sulochana Suryarachi, who is the Program Chair of MERCon 2023, and alongside her, Dr. Gaini Nandasiri, who is a Senior Lecturer in the Textile and Apparel Engineering Department. And this paper is in the track of special session on electric mobility, embracing and exploring the advances in electric mobility. And the best paper award goes to the paper titled Analyzing Key Determinants Affecting Electric Vehicle Adoption in Sri Lanka, a comprehensive evaluation, and it is presented to Saranjan Pakiyaraja, Tilakshan Tisai Veerasingham, and Saman Bandara.
And for our last track, Transportation Engineering. The Best Paper Award is for the paper titled Critical Evaluation of Transport Sector NDS for a Low Carbon Future. This award goes to Malimage Kushan Dilro Kaponsu, Saman Bandara, P. Saranjan. Thank you, madam. Please remain on the stage. Ladies and gentlemen, before we conclude the extraordinary gathering, I would like to invite the program chair of MERCon 2023, Dr. Sulochana Suryarachi, to deliver the vote of thanks.
A very good evening to all of you. On behalf of MERCon 2023 Organizing Committee, I'm privileged to address you as the Program Chair and as the Director of the Engineering Research Unit of the University of Moratuwa. As you know, this is the 9th version of MERCon, and we are coming back to physical mode after 3 years of virtual presence, and it was quite challenging. So, distinguished guests, Professor Ajit Dialvis, and all my senior professors and professors, heads of the departments of the Faculty of Engineering, University of Moratuwa, other officers. Most importantly, all this scholarly audience with researchers and my students who are supporting us. I would like to propose a vote of thanks, and there are a lot of people I have to thank, but I'll try to keep it short. First of all the authors who trusted MERCon and submitted their valuable research as manuscripts to MERCon. I should thank all of you. There were about 320 submissions. And then all the track chairs. We had a group of track chairs consisting of foreign affiliated scholars and faculty staff members. They took quite a lot of effort to assign your papers to the best people around the world who are working with us. And our reviewers, they took a lot of hard work to read your papers and give comprehensive feedback. Thank you, all of you. And I would like to thank, afterwards, actually, the things began. It was very hard, a challenging part of thing was holding the conference in physical mode. I would like to thank Faculty of Graduate Studies, who are sort of our platinum sponsor. I would like to thank Professor Aditya Alvis and all the research committees that granted us the grant for support for this physical mode funding. And then it's Dr. JR, who was a key person behind attracting multiple sponsorships, including our gold sponsor, Swisstech. And Dr. Varuna was able to attract the Bandaranaike International Airport as a sponsor. Actually, at the last minute, I would like to thank both Dr. JR and Dr. Varuna, who are part of, actually, they were key members actively working in the committee. And apart from that, there were 3 bronze sponsors, Octave, Metropolitan, and Apparel Tech. Dr. Jayamali, I should thank her, attracting, and Dr. Uday Sankar, and Professor Chatura De Silva, they helped us attracting these sponsors. And with the financial sponsorship of the university and these industry sponsors, we were able to bring a lot of value into our conference, particularly the keynote sponsors. I should also thank the Tool Conference, who sponsored the physical presence of Professor Shanika Karunasekara. And Dr. Logi, thank you very much. You added a lot of value by bringing Professor Jason Maas into, with his high profile. It added a lot of value to our conference. He even agreed to become our honorary chair. And Professor Buddhika Jayasekara, he was like a advisor, driving force, sharing a lot of experience about past MERCon, physical mode MERCon occurrences. And Dr. Gayani as the finance chair, Dr. JR as the one of our key program chairs, and Dr. Ranga Abesuri, I should really thank him. He did a lot of hard work to pull all these EDAS submissions into proceeding. It's a very hard work. And most of our research assistants from multiple departments, they comprised a team who looked at each paper, going through the formatting. It was a tedious task. I thank all of them for their hard work. And there are multiple parties. First, the venue, the civil engineering auditorium and other parallel sessions were held in different classrooms. Dr. Kasundi Silva, as our organizing committee member, did a lot of work to get the venue arranged for us. And the Center for Instructional Technologies, Mr. Sanjay Suryarachi and Mr. Shashi, today they are covering, and they have set up all this multimedia setup for hybrid mode. So I think you went through, followed the Professor Jason's session and Professor Trishanta Nanayakara's sessions virtually yesterday without any flaws because of their hard work. And I should also thank the Center for IT Services, Dr. Sunimal and his team, for providing all these networking infrastructure. Usually, like a lot of connectivity issues were there in this building previously. So for this conference, they took a lot of effort to restore Wi-Fi and all these connectivity problems are solved. And I should thank the institutional affairs, Ms. Suchitra, Ms. Prabodha, and their team for arranging all the procurement of your tasty refreshments and meals. I hope you enjoyed during the conference today. And most importantly, IEEE student branch. You will be surprised. All those students wearing this bright white t-shirts, they are all first years. they have just lived here in this university for one semester only. But look at their maturity. They have been handling everything: sessions, media, reception, registration. And you found that our compeer, she was reading certain words. It was not familiar to them. But it was like they're just first years. They're just after their schools, actually. So we should really thank. Until I told you, you may not even feel it, because they did it really nice. And the guidance were provided from the senior batches. Mind you, semester 2, 5, semester 3, 5, 7, everybody are on exams. They're in the exams. So only the 22 batch was available. So they could assemble a team of around, so you can see all these white t-shirts, if you count them, over 20 students, they could assemble in short notice. And they mastered and did the event really well. I should thank. And president of the IEEE student branch, Senel, is in the middle of exams. He will come and guide and look after the things are going on. And Shehan, every minute I sent him, okay, look, include this link in the website, that link in the website, he will do in a few minutes. So thank you very much. A big round of applause again for IEEE student branch of University of Moratuwa. Last but not least, I've sent a lot of invitations to all the deans, heads, and what do you call, the directors of various centers. But those who are present today, that shows that you value and you give priority to one of our key things. Like that's a capstone, the flagship conference in the country, actually, in this nature, multidisciplinary engineering conference. This is the best conference in the country, the international level conference. And I hope the enthusiasm, the priority that we give will be much more than this in terms of our participation, particularly when we take a lot of effort to bring real physical interaction with people, researchers together. So I think that part we should improve. And that is a huge change. Culturally, we should change into that. And I think we all can work together to bring MERCon, next MERCon, to that level. And if I have not read names specifically, please forgive me. It's a big team, organizing team, the technical committee, and the staff members from different departments, particularly Sunet from the textile department and his team. All these decorations, designs are from them, and we have sourced a lot of ornaments from textile department. Thank you, head of the department. And also from mechanical engineering department, we have pinched multiple items from them. And thank you, everybody. If I missed anybody, sorry. And all you, the audience, for being here with us. You added a lot of value. And I wish all you good luck and have groundbreaking research published in your future publications. Thank you very much.
Ladies and gentlemen, with the heartfelt expressions of gratitude from Dr. Sulochana Suryarachi, we come to the end of this momentous event. I echo those sentiments and want to thank each and every one of you for your active participation, insightful contributions, and unwavering enthusiasm throughout MERCon 2023. As we come to close on MERCon 2023, we would now like to rewind down the memory lane. Ladies and gentlemen, presenting to you the behind the scenes of MERCon 2023. Ladies and gentlemen, before we leave, we would like to take a group picture as a memory to go down our memory lane. Therefore, we cordially invite all of you all to join us in front so that we can take a group picture before you all leave. Thank you.